Hello students. Okay, today I am going to explain how to write the program for half adder in Dataflow modeling as well as structural or gate level modeling. The program which you can see here is Dataflow. Okay, so I need to know the Boolean expression in order to write the program. For example, if I consider this circuit, the sum will be equal to A XOR B. So this is a Boolean expression I will write. So carry is equal to A and B. So this can be directly implemented in the case of Dataflow modeling. So in the case of Dataflow modeling, I will be using continuous assignment statement. So this assign keyword, we call it as continuous assignment statement. Okay. So and then this symbol will perform the XOR operation, and this particular symbol will perform the AND operation. Okay, so I simply implemented what we have here. So I'll just give a syntax for the continuous assignment statement. So I'll start with assign target net equal to Boolean expression semicolon. So Boolean expression and semicolon. So I'll show some of the symbols which I can use for Dataflow modeling. So these are the operators in Verilog. So in that you can simply see this. So these are all the operators I can use for writing the program in Dataflow modeling. Okay. So here this is for AND operation and this is for NAND operation. So there is a tilde sign. So you can say that in front of number 1. So next to the number 1 key you can see this symbol. And this is XOR and this is for XNOR. So I will be using this cap symbol and I can use this tilde symbol. So I can put it in other way also. This also will work. Okay. So the vertical bar. So this is for OR operation. So vertical bar you can find above enter. Okay, above the enter key you can see the vertical. So this is vertical line, not any slanting line. Okay, it is not a division or forward or backward slash. It is a straight vertical line. Okay, that is OR. So if you use the tilde symbol, okay, which is next to number 1. Okay, so in your keyboard, okay, just left to the number 1, you can see the tilde symbol. If you have to use shift and type this. So this will become NOR operation. This will become NOR operation. Okay, in the class we already discussed how to write the program in gate level modeling. So now I'm going to teach you how to write the program in Dataflow modeling. For Dataflow modeling, mainly we'll be using these symbols. Okay, okay, this ampersand symbol I'll use for AND operation. If I use a tilde symbol before this, we can call it as NAND operation. Okay, so if I use a cap symbol alone, we call it as XOR. If I use a cap symbol along with the tilde symbol, we call it as XNOR. We call it as XNOR. Vertical line, I call it as OR operation. The tilde plus vertical line, I call it as NOR operation. Okay. So these are all the symbols you should know. So kindly make a note of it so that you can implement any Boolean expression into program. Any Boolean expression into program. So we'll come back to the program. Okay, so this is Dataflow modeling. I'll just write this program again so that you can understand line by line. Okay, so I'll start with module. So I already told you that module is a keyword. Module is a keyword, and next half adder, it is a name. We call it as identifier. Okay, so I can write as it is half adder, and there should not be any space between half and adder because it is a name. It should be continuous here. Okay, it is an identifier name. It is like a variable. Okay, so there are some rules for writing this identifier name. I can use alphabet, I can use 0 to 9 number, I can use underscore, and I should not start it with numbers. Okay, these are some rules we need to follow for writing this identifier name. And then within bracket I have to write the port list. So the port list is the one based on the signal which is given as the input to your half adder and signal which is coming as an output from the half adder. So these are all the port signals. Okay, the signal which you are giving as an input and signal which is coming as an output. We call it as port signal. So I'll write A, comma B, comma sum, comma carry. So these are all my port signals. So I don't bother about the internal signals, and then I am terminating the first line using semicolon. So that is very important. Okay, I have to terminate the line by using semicolon. Okay, now I need to declare the variables which you written in the port list. Okay, if you see this diagram, it is a hardware diagram. Okay, we are implementing a hardware diagram, okay, as a program. Okay, we are writing a program. So what we need to do, we need to specify what is this AB and what is this sum and carry. There are some way to declare in Verilog. The mainly we'll use input, output and in out. So these are all the declaration I can make for the signal present in the port list. If the signal is available in the port list, I need to use any one of this for declaring that. Okay, if you see this A and B signal, it will be acting as an input to the device which you are designing. So I need to declare this A and B as an input. Okay, so input. See, I am writing all the keywords in lowercase. That is very, very important here. Okay, all the keywords. The module is a keyword, input is a keyword. Remaining are not keywords. So your half add is an identifier. Your A, B, sum and carry are all are identifiers. So those are not keywords. Okay, here in the two line, module and inputs are keyword. It is input, not inputs. Input. Okay, and then we'll write the signal name A, B. So this two, and terminating that line using semicolon. Okay, you can write it in two different lines, input A semicolon, input B semicolon. Like that also you can write. So it is up to you. So next thing is I have sum and carry which is written in the port list. That will be declared as output because that is coming as output from the device. You can see that here. That is coming as output from the device. So I am going to declare that as output. Output sum comma carry. Output sum comma carry. Okay, so now I need to write the program using Dataflow modeling. For Dataflow modeling, I need to use continuous assignment statement. This is the syntax of continuous assignment statement. I already told you what is syntax. The syntax means what? It is like a formula for writing a statement. Here it will act as a formula. In that, assign is a keyword. So that cannot be changed. So I should write assign. So now I need to convert this Boolean expression into program. Okay, I already saw that. So this cap symbol is for XOR and ampersand symbol is for AND operation. Okay, so here this expression can be directly written. So sum will be equal to A. Instead of this XOR symbol, I need to use cap B. Okay, so this I need to write, and then carry will be equal to A. Instead of dot, I need to use ampersand symbol A and B. So in Verilog, in this case of Verilog, I need to write like that. Okay, so I need to use a symbol which is there in the data flow for writing the program. So assign. Okay, what is the output here? Sum, because I need to get this output. In order to get this output, what I should perform? I should perform the XOR operation of A and B. So that is what I am going to do now. Sum is equal to A. So in Verilog, for performing the XOR operation, I will be using cap symbol B semicolon. Okay, and then the second output, I need to use a keyword assign, carry equal to A ampersand B. Okay, and then I have written both the statements. I need to complete the program by using N module. So there is no semicolon for N module, and then there is no space between end and module. Okay, so this is a program I have written. For remaining all the lines we have a semicolon. Remaining all the lines we have a semicolon. Okay, so what is supposed to do? You need to follow the procedure. Okay, as we discussed in the previous video. Okay, you need to just create a project. Okay, in that you just type this program. Okay, after typing this program, you need to simulate this program. So how do you simulate it? You will be simulating by applying input to the inputs A and B. Okay, what do you need to check here in the simulation? I should apply the inputs and check what is your output. Okay, you just verify the truth table for your half adder. Okay, just verify the truth table for your half adder. Okay, so go through the truth table, apply the inputs and verify you are getting the proper output or not in sum and carry. The sum and carry. Okay, so if you have any doubts you can ping. Okay, so thank you students.